plastic bag is full, we throw it into the nearest landfill. It's out of sight and out of mind. What is the state of our humankind? And I don't know what to say, 'cause we produce more every day, and we call it garbage.
I'm standing here at the Commissioner Street transfer station, where a huge pile of leaf and yard waste is in the background. And, you know, one of the things we're trying to do here at Going Green for Green is change the mindset to where you once saw waste, you now see a resource. And over the last 20 years, certainly we've valued, and many years before that, we've always valued leaf and yard waste for its ability to be composted and turned into high energy efficiency fertilizer. So, you know, this is just one thing that we're going to be looking at. But overall, what Going Green for Green is about is trying to change your mindset when you look at waste and see it as a resource, whether that be plastics, organics, or anything else in our waste stream. We have to find alternative uses and ways to reuse what's already been made and placed on this planet before we take any more out of the earth. This is Going Green for Green.
Check us out online at www.goinggreenforgreen.tv or follow us on YouTube, Facebook, and Twitter.
Going Green for Green is brought to you by Ontario Electronics Stewardship and recycleyourelectronics.ca.
Here in the City of Toronto, Mayor Miller and his City Council have undertaken amazing steps to try to achieve 70% diversion from landfill. We will be the only city in the world to do so. And Mayor Miller has cleared his schedule to try and make some time for Going Green for Green, because he is a firm believer in the new economy and the businesses that are spinning out of the green movement.
I support what Bobby Kennedy said, which is what's bad for the environment is waste. What's bad for the economy is waste. When you get rid of waste, you have economic growth, and it's also good for the environment. And we see so much at Toronto City Hall of what can be done to create jobs, create efficiency, save energy, fight climate change, from simple things like retrofitting buildings to lower energy to very complex but important things like our methane recapture at both our landfills and through our green bin program, which collects wet waste and composts it. Extraordinary opportunities to create jobs, wealth, save money on city operations, and do the right thing at the same time.
Now, we did notice that the torch was burning. Is there plans in the near future to put a cogen on that?
Yeah, we're intending to recapture the methane when we have sufficient quantities. You need a certain amount to run a plant. So what we're going to do at the Disco station when volumes are sufficient is tap the methane, create electricity through it, and we'll use there'll be about 25 million tons, equivalent to about 25 million kilowatt hours. Right. And we'll use about 6.5 to run the plant, and another 18 or so will generate electricity. That's equivalent to about the electricity consumed by 2,000 homes. So what we're doing is we're taking what used to go to landfill, the wet waste, the food waste, we're composting it, turning it into methane, using it to generate electricity, which more than offsets the amount of energy used to run the plant. So it saves us money, it saves the environment, saves our landfill, and it's a clean, efficient source of energy.
Is there any thoughts in the City of Toronto to build multiple facilities and perhaps bring in organics from surrounding regions?
Well, we're going to build 2 facilities, one of them certainly would be capable of bringing in organics. We're really the leader, I think, in the world on our green bin program. It started in 2003, and it's ramping up. As you know, we've been very successful in single-family homes. Now we're going to apartment buildings and trying to do the same thing. Right. And so we're right now, I think we have about 125,000 tons of material that's composted. That's going to ramp up considerably. That's why we need the new facilities. But I think, other municipalities, as they get on board, are going to be looking for places to make sure they're doing the right thing as well.
Stay tuned. When we come back, Randy Clough is going to take us through the Downsview Organics waste processing plant that can take your green bin and turn it into renewable energy. This is Going Green for Green.
Check us out online at www.goinggreenforgreen.tv or follow us on YouTube, Facebook, and Twitter.
Going Green for Green is brought to you by the Royal Bank of Canada.
Standing here today out front of the Downsview Organics Processing Facility. Randy Clough, a representative from Canada Compost Inc., is going to be taking us around the facility here in Downsview and explaining how the process works and really what differentiates the BTA process from other composters and organic processors in North America. This is the only facility of its kind. It's been operating since the fall of 2002, and it currently processes a massive amount of organics. We're here at the tipping room floor at the Organics Treatment Facility, CCI's facility in Toronto, and the odor is really overwhelming. And you just get a sense of how important odor management is. Later on we're going to be looking at the biofilter, how this odor is dealt with, and how this facility operates with just really what is, one complaint a year during its operation. It's pretty amazing. Anyway, I got to get out of here.
This facility can process about 40,000 tons per year of the City of Toronto green bin waste. To put that in perspective, that's the equivalent of about 160,000 homes of the 510,000 single-family homes that are implemented with the green bin program in the city. So the waste gets dropped at the tip floor and then it gets loaded onto an enclosed conveyor. We can enclose the conveyors to manage odors. And you can see in here now that the waste is being loaded into the pulper. So after the pulper's gone through its routine, we pump off the organic pulp here in this component. And at the same time, we're also removing the heavy fraction, the glass, the household batteries, through this sieve trap system here. This pulp then goes over to a degritting system to remove the fine grit before it's sent to the digester. So once that pulp has spent its time in the digester, typically from 14 to 21 days, it's then removed and it's sent to these dewatering presses where the liquids are squeezed from it to create a solid. So once the digestate out of the digester has been put through those presses to dewater it, the liquids are treated and returned to the sewer, and the solids end up in this trailer here to be taken to make a final compost product. So our company developed 2 facilities here in Ontario. We're here at one today, the City of Toronto Dufferin Organics Processing Facility. And within this facility, there is a process implemented called the BTA process. That's the technology that our company has the rights for here in North America. And there's 2 major components to the process. In the building here, what you'll see is the first step, which is wet pretreatment. So when the city collects all of our green bin waste, it's delivered with a truck into that facility, and that's where the contaminants are removed and where the remaining organic fraction is pulped and created into a slurry. That slurry is then pumped off and put into this tank. This is actually the digester, as we mentioned earlier, works like our bodies and digesting our food. Within that tank, the organics are broken down into those 3 components: solids, liquids, and gases. The gas, as you can see, is captured and it's immediately available to create renewable energy. And that can take multiple forms. That could be cogening the gas that's created to create heat and electricity. That gas can also be used to create a high-grade natural gas that can actually be put in the pipelines. The other alternative is to also take that gas and make a liquid fuel, in the case of City of Toronto, the potential to power the municipal vehicle fleet using the waste from the curbs that we all put out. Several challenges when it comes to the diversion and processing of organics from a municipal waste stream. The fact that it's highly liquid requires different processing methods, and the fact that there will be inert contamination in the waste stream, irrespective of how well we do it at the curb and in our homes, those are contaminants that will still need to be managed. You can see a meat wrapping, you can see a can, a household battery. So it's very important to remove those contaminants. In our case, we do that up front so that we can maintain the downstream product quality in both biogas and the solids, which are typically turned into a compost product.
You know, the entire facility is automated, and we're here with Mac in the control room. Mac, just take us through again. What are we looking at here on these screens?
Basically, on the 2 screens here, the one on the left is an online trending package of all the measurements of the pulper operation itself. So I can compare what happened on a load, say, at 12 o'clock yesterday to a load that happened at 2 o'clock yesterday. Right now, we're producing approximately 900 cubic meters of methane gas per hour.
With the limited amount of landfill that we have left in the province of Ontario, there's been a number of steps taken to divert our waste from landfill and also maximize the value within that waste stream. Organics here, this being the only one plant in North America. However, in 2006, Ontario Hydro came out with the standard offer for electricity for green renewable electricity. This facility does qualify, and in the not too distant future, you're going to see a cogenerator taking the heat off that flame, turning a turbine, and creating electricity. And the amazing thing is if any of you guys have been around a dump or a landfill site, what really smells in the landfill is organics. I mean, it's the food waste that creates that pungent odor, which we know is the smell of the dump. And amazingly, here at this facility, with all the amounts of organics that we've seen coming and going from here, it doesn't smell. Again, right? We're all skeptics. This has been going on in Europe for a long time. They've been able to sort of hone down and work out some of the bugs. Randy, why doesn't it smell here?
And it's really because of the nature of anaerobic digestion. As you can see, this tank is where all the biology occurs. It's enclosed. If you think about your backyard composting, that's different. And if you don't go out and turn it, it's going to create odors, and you have to put oxygen in that. This is an oxygenless world. It's all enclosed, it's in tanks. The odors can't escape.
As we spoke about odors, organics, it's a stinky business. And this biofilter here, as simple as it is so effective. It's quite literally a pile of wood chips that the air just filters itself through before it comes out into the atmosphere. And quite honestly, the organisms in that pile of wood chips are what devour the odor. It's really quite an amazing process, and you have to tip your hat to the Germans who came up with the BTA technology. There's quite literally well over 1,000 of these functioning in Europe right now. So North America, we've got our first one right here in the city of Toronto. Kudos to the city of Toronto, but other municipalities, let's get with it. Let's see these things all across the country. Zero waste doesn't come easily. Stay tuned. We're going to be right back with Kevin Matthews, the CEO of CCI, and he's going to take us through the ins and the outs of organics and some of the difficulties he's encountered with his business over the last number of years. Stay tuned. This is Going Green for Green.
Check us out online at www.goinggreenforgreen.tv or follow us on YouTube, Facebook, and Twitter.
Going Green for Green is brought to you by Ontario Electronic Stewardship and recycleyourelectronics.ca.
There's two areas of challenges with source-separated organics. One area is actually getting the organics collected and being able to get a high capture rate from residents. The material is it's dirty stuff. There's a lot of contamination in it, and trying to get residents to participate and deliver as much as they can is a challenge that the city faces. And for the most part, they've overcome that challenge by allowing residents to dispose of material in plastic bags, which allows them to get rid of the yuck factor that's associated with the waste, and also allows them to have a fairly wide contamination rate in terms of the materials that they throw out. Challenge at the other end is being able to separate that material, and we call it digestible material and non-digestible material. And so the key is to be able to separate that material into the two fractions, and that's really where we come into play with our front-end cleaning systems, a hydropulping system, which allows us to pull out the non-digestibles and get a clean material that can then be fed to the digester for producing power. When you put in processing systems that are going to do something else with it, either produce energy, produce a compost, produce recyclables, the cost to do that is more expensive than the infrastructure of picking it up, taking it in a truck, and putting it in a landfill. The standard offer program that works today, or the feed-in tariff program, provides a much higher revenue value for the energy that you produce. And so that certainly has an impact back on paying back the investment for putting in the facilities. So on an operating basis, these facilities generally cost about $50 a ton. Let's just use that as a benchmark. Some are higher, some are less, but you have $50 a ton. At the same token, then you have the capital repayment on it, and that can easily be another $50, $60, $70 a ton. Over $100 a ton. When you put the two components together to deal with materials, especially in an urban setting, it costs more than $100 a ton. You have to offset that against what it costs them to send it to landfill, is it costs them all in $55. You know, we're in the anaerobic digestion business. 10 years ago, to say the words anaerobic digestion, nobody had talked to you. It was just not something that people thought was a feasible way to do it, and people wouldn't give you the time. Whereas today, anaerobic digestion is a very hot topic. It's proven. It's installed in Europe, and it's interesting. If you look at the road from the beginning of recycling through to at the end, where you're actually processing these materials and pulling off valuable pieces, Europe has been doing this far in advance of we've been doing it. They've been forced to because they have higher populations. They've got smaller geographic areas, and so they just can't pop landfills up here and there and deal with it that way. And so when I look at it, it's almost looking at hindsight. You look at what they're doing and the road they're going down, and while we're going down exactly the same road, the difference is we're going down the road faster. We're taking a look over there. We're seeing what they're doing, the decisions that they've made, the problems that they've had, and so we're able to streamline the process a little bit. But at the end of the day, we do follow exactly the same road.
Between Randy and Kevin, we now realize that anaerobic digestion takes place in a closed, contained environment without oxygen. Aerobic digestion is composted materials that take place with oxygen. George Scott has got a brand new facility in Kingston, Ontario, where they're launching their green bin program, and he's going to just give us the rundown on how his system works, and from a cost structure for smaller municipalities is a really neat way to go to launch a green bin program. Norterra Organics is the latest in organic composting in Eastern Ontario. So give us a little rundown on your system here and sort of the process that you went through that led you to choosing this system.
We first started to look into the organic processing aspects of waste and tried to choose the proper technology that would manage the organic stream with a very cost-effective, efficient manner. And we looked at a number of technologies. I sort of flew around the world and looked at gasification, looked at plasma arc conversion, looked at incineration, looked at this system which is known as the GORE system. And after my educational sort of foray around the world, we developed a strategy, an integrated waste strategy, where we can use certain technologies. In particular, this technology is the GORE technology out of Germany, and everything else is proprietary on this facility, but the GORE cover itself, the way in which that we treat organic waste through the process of anaerobic decomposition, is utilized through the GORE system.
So what is for the process to function from start to finish? What are we looking at in terms of, let's just say you've got your green bin waste, your table scraps.
Yep.
What are we looking at from start to finish before it ends up, let's say, in your closed loop on the sod farm?
It ends up, the program is about 6 weeks, 6 to 8 weeks. The longer you mature the compost, the higher quality you have. So once it finishes a system, then it'll cure. And depending on the quality of compost that we require, that is determined by the time it's spent curing. So this is a very unique system. As you can see by the bunkers that we have here, there were some very key concerns when I went to look for technology. There's some very key concerns that I was interested in when managing organic waste. The first is odor. We manage odor very similarly to other organic processing facilities in Ontario, where we have the tipping building under negative vacuum. But when the material leaves, it goes onto the GORE cover. And the GORE cover is a laminate membrane. So in other words, it's 3 layers of laminate, which allow simple molecules to go through or to migrate through the cover, and it does not allow complex chemicals or the smells, the H2S's, the chemicals that create odor. The compounds that create odor. It doesn't allow it to leave the cover.
So are you saying then that these concrete bunkers here will have this 3-membrane cover over its entirety?
Exactly. They'll be about 5 meters high, 8 meters wide, 50 meters long, completely covered, completely sealed. And another area you really have to worry about when you're building any facility under Section 27, Part 5 of the EPA is encroachment. What happens in 5 years? First of all, you can't devalue anybody's property around you. And second of all, what happens in 5 or 10 or 15 years if this land becomes very valuable? What happens if people, if a community wants to move in or get constructed down the street where you have 45 or 50 homes? Now, we mitigate all of the risk with odor control, but you want to make sure that if you get in a position where the actual land itself is more valuable than the process, you can take the process somewhere else. You can take it 10 more miles out of town. This whole system is completely portable, from the scale house to the tipping building to the bunkers to the bunker walls. Everything can be picked up in a week and moved.
Wow.
Yeah.
That's pretty thorough planning, George.
We have spent 2 years and working with our regulators from the Ministry of the Environment, working with councillors from the City of Kingston, working with the Planning Department and the other staff members in the City of Kingston. We've worked with neighbors to build the best system that we can come up with.
As we head towards zero waste, anaerobic digestion and aerobic digestion will both have their places in serving municipalities across Canada and around the world. There are many companies that are publicly traded right now that specialize in these two types of digestion. Today we find ourselves once again at the Molson Amphitheatre. Another great summer event here in Toronto. We're going to pop over and visit our friend Sean McGee at the recycleyourelectronics.ca booth, where he's going to take to the street and find out what Ontarians know about recycling their electronics.
Do you have any unused or unwanted electronics at home or at work?
I certainly do.
Yeah.
Yes, I would say yes.
Yes.
Do you have any old electronics at home or at your office?
God, yes, I do. Yes, at home.
Yes.
And what do you do with them when you know you've got them?
They usually find themselves somewhere in the basement until there's too much stuff there, and then I do recycle them.
Usually take them to the recycling depot. How do you get rid of it?
Well, I heard that there's a way to do it, but I just haven't had a chance to look it up.
I keep them.
I usually end up keeping them too.
I was going to take them to a place in Oakville that I know I'm supposed to take them to.
What do you do with them when you're done with them?
I take them to the Toronto Environment Days.
You're not throwing them out, you're recycling them. Why do you decide to recycle them rather than throwing them out?
It just seems like a waste, and I don't think that they're good for the environment if you throw them out.
We got a limited planet here. You gotta take care of it.
Well, when things go into a landfill, I mean, they're just there for forever. And so, if there's another place you can put them where it can go to better use, then why not do that?
Would you prefer to take it to somewhere that is going to recycle the electronics?
Yeah, absolutely. If I thought it would have the right outcome, I'm a huge recycler. Yeah.
And why are you into that? Why is that something that you care about?
I can't stand waste.
Have you ever heard of recycleyourelectronics.ca?
No, I don't know the name.
What if I told you that this is a program that is available for free use across Ontario, where you can go and drop off your old electronics at over 600 sites. All that you need to do is visit recycleyourelectronics.ca, drop off your e-waste, and then we'll make sure it either gets recycled or refurbished, and it's done in Ontario. What do you think about that?
I think that's great.
Recycleyourelectronics.ca.
Another plastic bag is full. We throw it into the nearest landfill. It's out of sight and out of mind. What is the state of our humankind? And I don't know what to say, 'cause we produce more every day, and we call it garbage.